Hi, math lovers. Welcome to notes number 141. We have one problem to work on today. I'm going to help you set up problem number 37 in your textbook on page 716. So if you don't have your book, pause your video, run and go get your book. Take a look at the problem, read it out loud with me as we go. Okay, and then we're going to set up the constraints. And then what I want you to do is I want you then to go to Desmos and graph it. I'm not even going to try to graph it here on my paper. That would be a disaster. Okay, so number 37. It says, an animal shelter mixes two brands of dog food. Brand X costs $25 per bag and contains 2 units of nutritional element A, 2 units of element B, and 2 units of element C. Brand Y costs $20 per bag and contains 1 unit of A, 9 units of B, and 3 units of element C. The minimum requirement amounts of nutrients A, B, and C are 12, 36, and 24 units respectively. Respectively means in that order. What are the optimal number of bags each brand should be mixed? What is the optimal cost? Okay, so this is an important question. We know that animal shelters don't have an unlimited amount of money to spend on their dog food, and they want to get the most bang for their buck. I really like that they say, let's let the 2 brands be called X and Y. That's so convenient for us. So let's let X equal brand X. All right, so creative. And let Y equal brand Y. Okay, so the cost of the 2 dog foods that they said are $20 and $25. So this is a $25 bag, and this is a $20 bag. If we could just give them all brand Y dog food, that'd be great. But I don't think it's going to have enough of what we need for all of these elements. So let's set our objective function, right? We want to find the objective function, let's call it C for cost, okay, is equal to, we'll do $25 for the first brand and then $20 for the second brand. So we're really looking for here is the minimum value. Like, what's the least amount of money I could spend and feed these little doggies? Okay, so we're feeding dogs. I need to buy dog food. I'm going to set up my constraints, right? The first thing I need to do is buy bags of X. So I need to buy a positive number of them, or 0. So I'm going to say X is greater than or equal to 0. And I'm going to say Y is greater than or equal to 0. Okay, so I've got 2 constraints already. Now I need to think about all these elements, right? They had element A, they had element B, and they had element C. All right, so let me read through this one more time. It said, dog food X contained 2 units of A. All right, so 2 units of A. So let's say 2X for A. 2 units of B, so that was 2X for B. And C, 2 units of C. Okay, we're going to add, because I'm thinking each constraint for each element, you know, so we knew that this had to be at least 12, right? And we knew B had to be at least 36, and C had to be at least 24. So I can figure out if I have 2 units in X, bag X, and then I find out that I had 1 unit in Y, then I can add them together, and then I can make sure that my constraints, my elements are met. Okay, so this says, go back to the way they say the minimum, let's see, 1 unit of A, so 1 Y, 9 units, wow, 9 units of element B, and 3 units of element C. Okay, so what I've done is I've come up with a constraint for each of the elements that are required here. Okay, now what I want you to do is take some time and I want you to go to your favorite graphing program, Desmos, okay? The best part about Desmos is you can type these constraints right as is. If you decide to go to your graphing calculator, you have to put each of these into slope-intercept form. So for example, this would have to be y is greater than or equal to negative 2x plus 12. You don't even have to do that in Desmos, all right? So you're going to go to Desmos, and you are going to graph these 1, 2, 3, 4, graph these 5 constraints, all right? Then you're going to find, oops, sorry, my paper's moving all over here. You're going to go to Desmos. You're going to graph, all right? So you're going to go to Desmos. You're going to graph the constraints. Then I want you to find the vertices. And then I want you to plug them into, plug vertices into the objective function. Okay? So that we can figure out which kind of dog food we should buy and how much we should mix together. Because it says, what is the optimal number of bags of each brand that should be mixed? What is the optimal cost? So they're asking for what is X, what is Y, and what's it going to cost? Okay, have fun.